Hello everyone, Prakrit and I will be showing you how do you use Gauss-Jordan elimination in a competitive programming environment or any question related to Gauss-Jordan elimination. I have two questions. I'll show you how the code works out, what's the complexity, and what is asked in a competitive world. So you guys are most probably very much familiar with what Gauss-Jordan elimination is. Basically, this thing is a method of solving linear equations. Basically, when you got many linear equations, you need to simplify it to get the variables, just to maybe to identify if there are unique solutions, or maybe if to identify how many unique solutions are there. Sorry, how many solutions are there? Either it's going to be unique, infinite, or no solutions. So, and it's a topic of linear algebras, and you can see here 3x minus y plus just z equals to minus 4. I'm going to plot all the coefficients in a matrix, and I'm going to add the constants here. And I am going to apply two operations, basically. Only two operations are which are valid. That is pivot operation. And by pivot, I mean if you need to swap the elements, and or the two operations are pivot. You swap Ri with some Rj and Rj with some Ri. You just swap the elements or totally row, or you can do a kind of linear transformation of row. Like Ri can be some A times Ri plus B times Rj. Something like this. You only allowed you to do this stuff, right? I'm going to finally simplify this equation into, if possible, if it's an n cross n, to a identity matrix, or if it's not an n cross n, to its RREF form. What is RREF? You can see row echelon form or reduced row echelon form is something like this, where the leading coefficients are there, and the leading ones follow our steps. You can see here. And reduce RREF is nothing but just taking this thing forward and subtracting all the remaining rows as well. So you can see if this has an 1, so all this will be 0. All the remaining ones will be 0, and this will be 0. So here I'm just going to subtract this row 2, so this becomes 0 and 0. Nothing much more fancy. That's it. So how do I write the code? If I give you a matrix, let's say first let's start with n cross n, right? If I give an n cross n matrix, let's call it A11, A12, A13 to some A1 and A21, A22 to some A2n, and like this AN1, AN2 to some ANN, right? What I'm going to do, I'm for every row, for I1 to n, for every column, I'm going to divide it by this value. Makes sense. So Ri, how do I transform Ri? First, Ri will be divided by A times Aii, right? I'm going to first divide it, and for Rj, that for j not equals to I, I'm going to do this operation Rj minus A. It's going to be Aij, right? No, it's going to be Aji times Ri. So if I do this, the columns will be 0 except for Ri, where AII, where it'll be 1 because I have divided this coefficient to be 1. So I'm going to, let's say I'm here, I'm going to divide this by A22 and subtract this row. Let's say this is R1. Let's say for R1 minus A12 times A22 by A22 into R2. So this is R2, right? So if I do this, this thing will become 0 and this thing will be 0, right? So I'm simply going to do this. So what's the way? So let's call this Gauss-Jordan elimination function for I equals to 0 to n. And this is basically the column. Since I'm going this way, my row is fixed, which is going to start with the column itself. And I'm going to find a maximum value. Why maximum? It's not necessary to swap the rows, but it will make sense. Why? Because when I'm dividing by some values, it is most helpful for me if I divide it by some larger values instead of some small values. When I divide it by extremely small values, right? This thing will overflow and the value will start becoming way too big. And if I try to multiply it eventually with some other constant, which I'm doing here, like select this will cause some very big issue. So instead of that, I'm going to divide it by the largest value in the row, sorry, in the column of that particular coefficient. Then I am going to find out this thing. So just for that, I will be using the swap operation. Just it's going to find the maximum value for I plus 1 to n. I'm just going to find the maximum value and I'll swap this, and swap row is nothing but just O of m, where m is the size of the column operation. And then again here, I'm going to apply the transformation. That's it. How the transformation works. For transformation, for the current row, I am going to divide it by the current coefficient. And for every value, for every other row, I am going to multiply their coefficient with our matrix value. That's it. Now, what's the complexity of this thing? Uh, sorry, complexity. We are going this way. I starts from here, I to m. Let us m be the call size and n be the row size, right? For I is going to m, and for there we yeah. Where is it? Yeah. For I, I'm just going to write it here. I am going with O of m into this whole thing works in O of finding the pivot is O of n, because anyway it will be n minus 1 and minus 1 adds up to n. That's fine. Then swap rows is another O of m plus apply transformation. This thing is another m into n operation because you are again multiplying everything. And so overall the complexity becomes an approx of O of m square n. Now this is a very heavy operation. You can see if n equals to m, this becomes an overall n cube operation, right? This becomes a very tedious and very highly competitive and to be worked out in an competitive world. But sure, this thing is usually done in the ML thing, this ML process to find out the variables and all. For the competitive world, this is kind of heavy, but still, we will try to do some other methods how we use this to find solutions to our problems. For general MNN, it's not possible to make it to an identity matrix. So what we do, we skip columns. When do we skip columns? We skip when we don't find a positive integer. That's it. What do you call it? Non-zero value. We don't find a non-zero value. So you can see here, if I'm at here, I found a non-zero value. I did the operation and made everything else to zero. I found a non-zero value, everything else to zero. When I started here, I didn't find a non-zero value. Again, I will go. I didn't find a non-zero value. And here I found a non-zero value. I made this one and made this zero. Again, didn't find a non-zero value and just made this one. And we don't have any other operations. Uh, this is just to skip and don't increase the row. We won't do row plus plus if we don't find it. That's it. Uh, so you can see here, Gauss-Jordan, the code remains the same. I'm just going to change this code. Uh, Introduce new sizes. That's it. For row, we'll just initialize first row here. And if I find this thing, and if my maximum value is my maximum value should be around less than 1e minus 9. Yeah, if it's almost negligible to zero, right, we will ignore it. Or we will just continue it and we won't swap the rows or apply any transformation or increase the rows plus. We increase the row. So just continue it and if I find something, a positive number, we're gonna apply this thing. That's it. Uh, that's our code for our general n into m case, right? The swap rows and apply transformation remains the same for a general n and m, but just have to change the loop values. That's it. In competitive world, yeah, the code discuss deals more in ML worlds to find linear equation solving matrices and all. But in competitive programming world, we prioritize exact solution using modular arithmetic. Modular arithmetic in a sense, we have set of linear equations. We instead of finding it to some constants, we find if it's something mod p. If it's something mod p. Now this changes the game. Why? This way we will be able to find out. Uh, I'll give you one case scenario. We wanted to find if there are n equations. There are n equations. We wanted to find out if that adds up to some even values. So instead of taking some different big large p, we'll just make p to we'll just make p to 2. So anyway, b1 will become b1 mod 2, which will give us either 0 or 1. So we'll just have to find out the solution for anything like this for 0, 0, 0, 0, like this. If it adds up to even numbers, right? Because that one will be 0, 0, 0, 0. So we'll use the exact this idea and try to solve some questions. Okay, so how do you implement this mod B? We'll just have to mm, make sure while multiplying, we just add this. Just when I'm multiplying, just take the mod. And when we were subtracting, also just take the mod. But when we are dividing by some value, right? AI, we need to make sure we take the inverse mod because it's not possible to divide it and take the mod. So we're just going to take it into the power 2. So that's nothing but pi. If I'm dividing a value a by x, I'm just going to do a into x times p minus 2 mod p. So I'm just going to do this. So x here is your value and x times p minus 2 is your mod inverse value. So I'm just going to do this. P minus 2 will take care of this and the mod. So just a similar thing as that. Um, After that, I can just move forward with the question. So, trick. We talk. I'll give you a question about this. All right, we have one question. If I'm recording. Self. Okay, I'm recording. Cool. Uh, this question is a code force question. Problem states that if for some array A, find a number of different ways to select a non-empty subset of elements in a way that the product is equal to the square of some integers. Just make sure this is non-empty subset, right? And find the answer modulo 1 that's fine. Two ways are considered different if the indexes are different. So even if I have 2, if the index are different, they are considered different. That's good for us because that will play an important role in our solution. How, right? All right. There are many ways to solve this question. One way that strikes in your mind is DP, bit masking. Why? Because the values of AI are less than 70. So, and the number of prime numbers less than 70 is only 19 prime numbers are there. So we can just make a DP bit mask, figure out DP of, let's say, I and some 19, and figure out if the previous element was zero, the number of elements is either mod something like this, mod 2 or something. You just need to figure out if the factors of AI when P was taken is number of P was taken is divisible by 2 or not, something like that. We can try doing that approach, and it will be fairly simple and a trivial way of doing it. But I want to show you how this question can also be solved by linear equation. How you can try to figure out a linear equation and use Gaussian elimination to solve this. All right. What you asked actually, we are asked that we are asked if a set is there. Let's A is the subset, so we make the subset of A, and the product of so on to let's say cardinality of A is something like this: A1, A2, A next, right? And product of AI is some kind of number. Let's call it n. We want to make sure that n is a square number, right? So if n is a square number, we have to make sure, and it is totally obvious, that if I try to prime factorize n with all the prime numbers, let's say n is nothing but p1 to the power b1, p2 to the power b2, and that's the 19 prime numbers, p19, something like this. This n can only be a perfect square when all these powers of bi mod 2 should be 0 for all I. Only that way it will be possible, right? So I can try figuring out some methods. What if I make represent AI in a vector, two-dimensional vector, 1 cross 19 vector, where it will be either 0 if pi doesn't divides ai, else 1. So I'll have a vector of some kind of stuff like this. If it is, let's say, ai was 4, our vector will be nothing but 0, 1, 1, and 3, 4 won't divide, something like this. And all of them was 0 also. So if it is 4, the vector can representation can be like this. All right, we can represent this kind of vector for everyone. So let's say A1 is something like this, A2 is something like this, A3 is something like this, A4 is something like this, AN. So everything we can represent some kind of 19 cross vectors, right? And we want to make sure the value we choose, uh, let's say we multiply each of them with some xi. This x will tell us if we are selecting the vector or not. Mm, X will be nothing but n cross 1 selection vector. We want to make sure if x is either 1 or 0, uh, so n cross 1, right? So this will tell us if we are selecting that element or not. Now we want to select in such a way that the XOR of all these elements, or we can say the number of elements that are add up should be even, right? That's it. So we found a linear equation. What is it? We found a linear equation. Then we want to make everything an even number. This becomes a 20 cross uh, n, and here is AI representation A2, A3, right? So we want to make sure this thing is there, is 0. How? When we make the mod p to be 2. So this will give us a solution. We want to find number of solution. This will give us, we want to find number of such x, right? How do you find that? This is simple because we want to find how many free variables are there. All right, to talk about free variables, I need to introduce you to the word called rank basis. Maybe I can tell you about how the equation works. So basically, if I give a set of vectors, right? Basis vectors are the orthogonal vectors, a set of orthogonal vectors that can be used to make up every other vectors in given vector space. So if I give you, let's say I give you 15 vectors, you feel like all of them are unique, but no. What do you do? What do you find out REF of that? You find out REF, and you found out that there are, let's say, X number, let's say only 4 rows where, non-zero rows. So every other got cancelled. So what does it mean? I only need four vectors. I only need four vectors to make up to the vector space. So with these four vectors, I can use some linear transform like AX, A of V1 plus A B of V2, something like this, and finally make the remaining vectors, missing um, 11 vectors. So this way I know that this are the four vectors are there. So what is 4 here? 4 is the rank of the matrix that I gave you. And how do I find rank? Rank, nothing but just the number of non-zeros, zero rows in their respective RREF. So that's it. And in terms of linear equation, what does it mean is, if I give a set of linear equations, there are, and I applied some RREF transformation. So I applied the transformation just to get the RREF. What happened is some equations disappeared. Some equation disappeared. So the coefficients of some variables disappeared. What does that mean in actual life? It means that those variables are free. So you doesn't mean whatever the variable value you apply to that variable. Eventually, when you're trying to find this equation solution, the variables will the coefficient of the variables will become zero, and the variables will have no effect. So the number of solutions will eventually become infinity because you can apply any value to that. Here, instead of applying any value, we can only apply either 0 or 1. We can either choose or not choose. So if we find the rank of this matrix, we'll know how many free variables are there. How many free variables are there? N minus rank, right? So this many free variables will be there, and we can apply any value to it. Here, any is either 0 or 1. So I have two options for it. So I'm going to do this, and I'm going to minus 1 where I didn't apply any variables. So this gives me the whole answer to this problem. That's it. This simply, I did this and I'll get the answer. So how? This is my solve function. I am just going to find Gauss-Jordan, and this will make the matrix to an RREF form, and I'm just find the rank. How do I find the rank? I start with the lowest row, and then for each column, I'll find if there is a non-zero, I'll break it because my RREF is already formed in a way that the zero rows are at the bottom. So if there's non-zero appears, all of them will be non-zero. That's it. So, if I get a non-zero, I'm just going to return the C. If I am getting 0 rows, I'm going to add up the value. I'm just going to return the C. That's it. And how I'm going to visit vectors. So you can see the last row is 0 because it's going to be 20 cross vector instead of 19 because we want all of them to be 0. And for each value, we find if pri is equal to 0. We don't need to do this though. I mean, just I did it. Doesn't matter. If we can just, instead of this while loop, we can just make it if pi like this is 0, then I'm going to make this to 1, or else I'm going to make it to 0. That's it. That's it about the code, and I'm going to use the same code, Gauss-Jordan elimination, to find the rank, and I'm going to find the power to the thing. And while taking power, I'm to make sure that I take the mod of 1e9 plus 7. Uh, for this reason, remember, I had two codes of power here. Here, I was taking one of them, I was taking the power to be actual 2. You can see here, because I was using mod inverse, and the remaining ones, I was just using this mod was initialized to 1e9 plus 7. I can show you the code. I can share the code, but that's very fine, I guess. I'll just move on to the next question. How much time do you have left? 3 minutes. All right. I'll try to wind up in 40 minutes. 45 minutes. It's possible. All right. The next question is another one. Here's a question. What and does LSR task? I'll just open my code here. All right. What is the question? The question I'm going to try. Oh, there's a missing here, right? Hmm. Okay. Uh, We were given an array of integers, AI, AI to AN, then we want to find out, and we're given n q queries, integers L and X. For find a number of subsequents for the first L elements of the array such that the bitwise XOR sum is exactly X. Now, how do I find the bitwise XOR? Mm, I given n and q. I'll give you some time to figure out what we can do. Just imagine this whole, you can not given any n queries instead of only one query that is just find number of subsequents for the for first n elements. I mean any subsequence such that the bitwise R is exactly X. How do I find this? Hmm. Let us try to represent X in terms of in its binary form. It's going to be something like this, right? And let us represent a set of numbers a1 and a2 was selected, and it came out to be some kind of values, something like this. When will their bitwise XOR be equal to this? If I take mod p to begin to here and represent ai in its binary form instead of this, represent binary form and find out a1, a2, a3, dot dot dot, an, and there will be a selection vector which is going to be again either 0 or 1, and I'm going to find out there if the value is equals to the x. So my last column will be x represented in the binary form, right? Uh, that's it. And how do I exactly find this? We're gonna find it by how the thing is, how do I fix this x? Now this is a selection vector. So let's say total number of ways how this can be selected is 2 times 2 to the power number of free variables again minus if I put x, right? If I put x and if my rank didn't change, what does it mean? Mm, yeah. Uh, if I've taken already x, right? So my number of variables will be this. So yeah, I can see the code here. If I'm going to find the rank with x and find without x. Now my idea is that if I put x there, all right, and this whole value row, we're stuck with the solution right now. The thing was, how do we deal with multiple queries? Now, hint is we only need to care about the rank until ith index. So if you have any idea about how can we be done, And what are the things that we need to take care about? First of all, if we need to care about only the ith index and for some jth index, we can try finding out, try to maintain the matrix parallelly. Matrix stats. So what do you mean by stats? I don't need to know every value of a matrix if I'm having. I just need to know till the ith index which are the pivot values. Mm, let's see. First of all, I always need to know what the rank is. Secondly, I also need to know what are the pivot values. Only then, if I get a new value just to put here, I can see if that pivot value was already there or not there, right? I can try computing this parallelly with the analysis, but also, if that gives us till an ith index, so we can answer the query in a sorted IRIF index forms. So of course, for that we need to do an offline query, sort them based on the index. And based on the index, I've sorted it, and I'm just going to query it from I equals to 1 to n for every ith index, whichever was there. I am going to find the rank till there and see if putting x value changed my rank or not. Something like that. All right. But the thing is, the main problem is how do I keep track of the matrix? Hmm. Okay, for a matrix, the pivot elements are nothing but this things, right? I'm just going to copy this. All right. Let's say this was our matrix. For pivot elements, the pivot elements are this one, this one. All right. Uh, Now how do I take care? Let's talk about first. I insert the ith element. Sorry, one first element. So my matrix will look like something like this. Nothing but just 1, 0, 1, 0. If my first element was like this, A1 was like this. So my matrix will look nothing but just 1, 0, 1, 0, 1, 0. All right, cool. Now let's say I've inserted another element. 1, 0, 0, 1, 0, 0. So I'm going to put here 1, 0, 0, 1, 0, 0. So my RREF now can change to something like what's going to be my RREF? 1. So I'm going to divide everything by 1 and I'm going to subtract this with 1. So this becomes 0, 0, minus 1, 1. That becomes again 1. I'm taking a XOR operation here because it's going to be mod 2. So it becomes again 1. This becomes in one itself thing. Scary. One and zero. Right? So we need to figure out these changes. When we did this, my pivot value became this one and this one. Right? So if I put another elements, one, zero, 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 one, zero, zero, something like this. This was my pivot elements, and I am going to subtract this with this. So this element again becomes one, zero. All right. So I just need to care about what the pivot elements were, and if just see if my pivot of ith bit was zero or not. If it was zero, then it's fine. If it was zero, that means I didn't get anything. And if it is one, that means I got a value where this element was one. So I'm going to change it. So I'm going to change my pivot element. And if else, I am not going to change it. Now my idea is that for every index, I am going to keep on inserting like this and just check for if the pivot element changed or not. The pivot element changed, and I'm just going to update it. And now, how do I take care of this operation? So the thing is, the matrix operations where there's some kind of lots of operations would have been done, right? So if this was the pivot element, uh, so what is the status of the value right now? All right. The thing is, for every index, only odd number of pivot values should be there. Should be there. Otherwise, if there were even values, the remaining will become zero. So we don't want that to happen because if there's a pivot, it needs to be there only when it'll be there when it's the number of occurrences of pivot in that row is odd. How do you take care? We'll just initiate a variable with AI, and every time I encounter one in ith bit, I'm just going to do a XOR operation with var mm, XOR equals pivot of I. So if there's a XOR operation and there is a pivot, I'm going to just click a XOR. And for every bit, I am going to just simply do that, right? Uh, if not, I am going to put the value. Fine. Uh, I'll do this. Now, the thing is, now how do I? No, now how do I take care about this whole operation in a simplified form? I'll do this then simply when I get a query called X, we're gonna see if is a pivot value for the ith bit where ith bit of X is equals to 1. We need a pivot value to make it 0, right? That means we need some row, the ith row should contain odd number of ones. That means it's that, nothing else. So if it's there, then we are good to go. If it's not there, if it's 0, that means this is not linearly independent, not linearly dependable. So my rank will increase, and rank will increase. That means there will be no solution. Otherwise, I'm just going to take it to the nothing but the number of pivots or just the rank, I minus rank. So this will give us the solution for the ith bit, ith position for a query called X. So that is the solution. I will show the code here. Uh, First, I'm going to make a struct of the query just so that I can sort them. I think the sort based on the L. That's it. I'm just going to take the queries and I'm going to sort the queries. Now, for the pivots, it's nothing but it's compressed matrix. It's going to be either 1 or 0. The thing is, just going to for every query, I am going to take the value of initialize var. You see if the number of odds, if the number of ith bit is even or odd, then I am going to, for every bits, I am going to just see if the bit is or if the bit is not already there, then I'm going to increase my rank and I'm going to set the pivot to the val, right? And else I am going to do a pivot. That's it. And for while I get the query for the ith, see which are the query for this kind of index. You just get a query and see if it's possible or not. If it's, how do I know? If I don't find it, pivot for that element, which is 1, and that means it's not possible. So I'm just going to break it. Else, again, I'm going to take the stem, XOR equals pivot bit, and try doing it for every XOR and find out if it's possible. If it's possible, then good to go. Uh, and just increase the query rank and just see what the answers. That's it. It was a kind of very tricky problem. The way to do it was kind of it's way farther away from Gaussian elimination. But the idea is that if I give you a new value, you just need to check. You just need to check, will my rank increase or not? That's it. If the whole purpose was to keep a track of the rank, and how do I keep a track of the rank? I'm just going to keep on seeing the values of my pivot. That's it. Well, this was the answer. I'm going to pause here and I'm going to stop this thing.